Okay, we're going to work with perimeter and area. We'll read our question here, and we've already chosen an answer. We've got to figure out how on earth we got to that answer. Okay, so even though I crossed out his name, I think it's Mark, has a garden that is made up of 3 square sections, and they've given us a diagram in this question. These are our 3 square sections. It's a very odd piece of land to own. Anyways, he builds a fence on one side of the garden, and we go on the assumption that they're talking about this side of the garden as opposed to this, because that would be very awkward to build a fence around. Which of the following is closest to the length of the fence? Okay, so here's our letter R or L. We got to figure out the length of the fence. Well, they've given us 3 pieces of information. They've given us the area of each square section, and that's very, very important. Okay, because we want to figure out what is the area of a square. What's the general formula for it? So, area. I'm going to put a little s here for of a square. Area of a square is length times width. Okay, that's the area of any rectangular object. But what's special about squares is their lengths are equal to the widths. They're the exact same. Well, otherwise, it's not a square. So what that means is I can replace the letter W with L, or I can replace the letter L with W, which really means I can just say it's, and a lot of times they describe area of a square like this. A is equal to sides squared, whatever the side is. We can just represent it as the length squared, or you could represent it as the width squared. All of these are correct, okay? All of these are technical definitions. We're going to call it area of a square is equal to the sides squared. So area, and I put it, this is called a subscript, okay? It's just so we know we're talking about a specific area of something, of a side square. Okay. Well, slowing down on the computer, what's going on? Give me 1 second. Oh, that worked. Oh, there it goes. That was square. So, what piece of information have they given us? Well, they've given us the areas. So that's not the sides, that's this thing here. So we're going to replace 3 different times the area in the area formula, we're going to replace the area with these measurements. Okay, so area is actually 11.56, which is equal to s squared, and we'll call this square 1, like the shopping mall. And we want to isolate for our letter s because we want to find the side length. And why the side length? Because we're going to end up adding one side length. Let's get bigger. One side length plus another side length plus another side length. So we're going to need all 3 side lengths here. So how do I get s by itself if it's squared on one side? We have to use the opposite operation. The opposite operation of squared is the square root. So whatever you do to one side, okay, so I'm actually going to square root this right side. I have to square root the other side also. Now, on the right side of the equal sign, what ends up happening as these things, they technically create a exponent of 1, but for all our intents and purposes, we're just going to say they cancel out. Okay, that's what a math teacher will tell you, they cancel out. So now we have side is equal to the square root of 11.56. Okay, well, we're going to need a calculator here. I forgot to sign in, so I can use this old one here again. 11.56. Square root it, and a square root here on the calculator, see how it has the number 2 and then the root sign? That's a square root, okay? Sometimes there's no number there. It's implied that that number is the number 2. Okay. 3.4 is our square root. So our side length is 3.4, and what's the unit? It was meters squared, but now length is only 1-dimensional, so it's just meters. Okay, so right in blue, this is 3.4 meters. That's the length of this side. We're going to repeat this process 2 more times. I'm not going to go through it in as much detail since we now know that all we have to do is square root these. So I'll set it up again. Area of a square is equal to the side squared. The area we were given is 6.67, so 6.76, equal to s squared. Another way of thinking of this is if I move the square to the other side, it becomes square root. 6.67 is equal to s, and then s is equal to, we bring out our calculator again, 6.76 square root. Whoops, that was the cube root. 6.76 square root, 2.6. So the side length of the middle square is 2.6 meters. And finally, the last process, I'm going to go through this one very quickly. We already know it's A equals S squared. We know we're going to have to square root the area, and the area is 21.16 is equal to S. So I've skipped quite a few steps. So slow here, faster in the middle, and very fast on the right.
Yeah.
Our side length is going to be 21.16 square root of 4.6. Great. 4.6. So this is 4.6 meters. Are we done?
No.
We've got all the side lengths. What do they want to know?
What are they added up?
Yes, what would the entire length be? Which is not quite perimeter, but it is the length of one side. I probably shouldn't have called this perimeter. So let's add the three of them together. When we add the three together, we get 3.4 plus 2.6 plus 4.6. When I add this, I'm going to get 10, 16, carry the 1, 5, 6, another 10. 10.6 meters. Is that an option when I scroll it up? Yes, it is. 10.6 meters is our answer in this question.